Hi guys, happy Monday. So today we're going to talk about diffusion and osmosis. So you should have the notes pulled up and you should be filling them in. The front of the notes looks like this, osmosis notes. Now the back of my notes are handwritten, but you should have these exact definitions or words to define as I go through them. So the first is diffusion. So diffusion is what we talked about this past week, right? So the starch and iodine lab. So that iodine that moved through the cell membrane, aka the dialysis tube, and into the cell, into the dialysis tube, and mixed with the starch. Okay, this is called diffusion. It is the movement of a substance across the membrane from a high concentration to a low concentration, right? So outside of the cell, there was a very high concentration of iodine, right, in the beaker. It was very yellow or auburn color. Inside the cell was a very low iodine concentration, right? It was just starch. So it moved from the outside into the cell from a high concentration to a low concentration. Okay? So diffusion, facilitated diffusion, and osmosis are our three types of passive transport. You need to note that. Three types of passive transport. Now, passive, what that means is it just happens, right? It's random, it's just going to happen. Active transport's what we're going to get into later this unit. And that's one where it's like, boom, moving through the proteins, okay? It's like working through it. So passive is just the random movement of molecules. So diffusion. The second is facilitated diffusion. So molecules that move across the membrane using a transport protein. So they kind of, go up to the protein and say, hey, can I get through there? And it sends it through the channel. Okay? So diffusion is just the movement from a high concentration to a low concentration. Facilitated diffusion is a movement across the membrane using transport proteins. So the integral proteins that we talked about last week. Osmosis is a little bit different. Osmosis is the diffusion of water. So osmosis is where water molecules, so water moves from areas of high concentration to low concentration. So specifically, osmosis is a type of diffusion, but osmosis has to do with water. Okay, so water moves from a high concentration to a low concentration. Okay. So what is the difference between diffusion and osmosis? So diffusion is the movement of molecules from a high concentration to an area of low concentration, whereas osmosis is the diffusion of just water. Okay, so we're talking about water here. So this is the difference. Diffusion is a movement of any molecule from high to low concentration. Osmosis is specifically the diffusion of water. Okay. Now these two words are very important for the next part of the notes. Solvent and solute. So solvent is a substance that is dissolving the solute. So solute is a substance that is dissolved. Now, let's take a minute. So let's compare it here. If you've ever had Kool-Aid or Crystal Light lemonade, that is going to be your solute. So if you look over here, Kool-Aid is the solute. It's the powder that you put into your cup. Water is the solvent. It's the substance that's dissolving the solute. Okay? So solvent is water, usually doing the dissolving, and solute is the substance being dissolved. It's the tiny particles in there. So this week when we look at our gummy bear lab, you're going to do sugar in water and salt in water. So sugar in the water, so sugar is going to be the solute, what's being dissolved, and water is the solvent, what is doing the dissolving. Okay, same thing with salt. Salt is a solute, what is being dissolved, and the solvent is water, what is doing the dissolving. Okay, so think about this Kool-Aid example or Crystal Light lemonade when you're thinking about solute and solvent. Okay, last but not least, concentration gradient. It's the difference between two solutions. That's it. So in our case, we're going to be talking about the outside, like the beaker, like the iodine, and then the inside, the cell. Okay, so we're going to be talking about cells. So here's your cell, and then the outside of the cell. What liquid is it sitting inside of? Okay, and the concentration gradient is the difference between the cell and the outside of the cell. What is the difference between their solutes? Which one is more salty? Which one has more sugar? The cell or the solvent, right? What's on the outside? So concentration gradient in all types of transport, so diffusion, osmosis, and facilitated diffusion, substances move down or with the concentration gradient. So from high concentration to low concentration, they are always trying to reach this equilibrium. We want equal amounts of water and equal amounts of solute. So how we reach that? We reach that by our water moving, okay? Moving across that concentration gradient, moving into the cell or out of the cell, depending on the situation. So let's talk about the situations, okay? So now what I'd like you to do is pause me, okay? I'd like you to pause me and I'd like you to fill out these notes, okay? This top box. Now I'd like you to pause me and fill out this box, these diagram boxes. Why am I asking you to pause me? Because if you're trying to write, you're not going to listen to what I say, right? So pause me, fill out these boxes. Okay, here you're going to cross out the word example and write definitions. And then you're going to fill out these boxes. Once you have all of these boxes filled out, then you can hit play. Okay, so I'm going to stop now. So stop and pause me. Okay, welcome back. So let's talk about each of these. Hypotonic, isotonic, and hypertonic solution. So in these, we are talking about osmosis. So the difference between the cell's concentration of solutes and the outer liquid's concentration of solutes. So in a hypotonic solution, isotonic solution, and a hypertonic solution. So in a hypotonic solution, let's start with the definition. Hypo means less than the cell, okay? So this means that a hypotonic solution would have less salt or less solute than the cell itself, okay? So in a hypotonic solution, the solution has fewer solutes on the outside than the cell. So AKA, the cell is very densely packed with solutes or salts. So the water moves into the cell to dilute the cell. So let's talk about this. So the outside has less salts than the actual cell. So the cell is very salty compared to the solution on the outside. So what happens? We want to reach that equilibrium. So to reach that equilibrium, the water is going to move from this less salty outside and move into the cell. So this less salty outside water is going to move into the cell to reach that equilibrium, to really water out that salt on the inside. So what happens? The cell swells up with water, and as the water moves, it dilutes it, right? It causes that salts to become diluted, but sometimes the cell can burst, and this is called lyse. We lyse the cell. It bursts. It becomes too big, too quick, and it busts, okay? Now, when you do these, you always want to label hypotonic and hypertonic. So so let's jump over here. Hyper means higher than the cell. Okay, so look, it means greater than the cell. So a hypertonic solution out here means it has more solute in the cell. It's really salty compared to the cell. So AKA, the water in the cell wants to balance out that saltiness with its environment. So this water from the cell will leave the cell and enter the surrounding solution to try to dilute that saltiness. So what happens? Well, if all the water leaves the cell shrinks. And as the water leaves the cell, it moves into the super salty solution called hyper. Hyper means greater than the cell, okay? Now, hypotonic means less than the cell. It's less salty than the cell. Hypertonic means more salty than the cell. What do you think isotonic means? So isotonic is a solution that has the same amount of solute as the cell, so they're equal, right? So the water won't move one way or the other. Now, water is always going to be exchanging, but it's going to be exchanging in an equal ratio, right? So not everything is leaving or not everything is coming into the cell. It's equal ratio here. So the H2O is the same on the inside as it is on the outside, as well as the solute is the same on the inside as it is on the outside. So iso means same. So the cell and the environment are in the same solute and water ratio. Okay? So to recap, hypo means less than the cell. So the surrounding solution has less solute than the cell. If it has less solute than the cell is very salty compared to the surrounding environment. So the water is going to move into the cell, it's going to grow really big and maybe bust, called lysing. Isotonic means they're the same. And hyper, meaning more, so the solution has more solutes than the cell, aka the water is going to leave the cell to balance out that salty solution on the outside. Okay? All right. So this was just a brief introduction. We're going to be working on this, doing practice problems, but please fill these notes out, have them ready to go tomorrow. Okay? Bye, guys.